Welcome to this new playlist about direct policy search and reinforcement learning. This playlist is a follow-up of a lecture that I already put on YouTube about policy search methods, where I was explaining how to optimize the behavior of a robot by sampling trajectories and increasing the probability of reproducing the most rewarding trajectories and changing the parameters of the controller of the robot thanks to the corresponding signal. So in this class, I will distinguish between two approaches, policy gradient approaches and direct policy search methods. And the topic of that particular playlist is to compare both approaches and show also that we can combine them. Before going further, let me say that this is a topic that matters a lot to me because I have published on this topic since a long while. So the first paper about this was together with Rex Dulp, where we compared covariance matrix adaptation methods and some path integral, which are reinforcement learning methods, and showed that they had some common core. And then we went further in these comparisons. We wrote together an overview of policy search presenting both views. And finally, much more recently, I have also written a paper about the methods that combine evolutionary methods or direct policy search methods and deep reinforcement learning methods for policy search. So let's start again from the policy search context and with the most simple algorithm that one can propose. So imagine that you have some controller with some parameters. You want to optimize your controller. What you can do is pure random search. So you take a set of parameters for your controller, you evaluate its performance, and then you sample another set of parameters, you evaluate the performance again, and if the new performance is the best so far, you keep it, and you do this until the performance you reach is superior to your target or until some time where you will just keep with the best one you have found. Of course, if the space of parameters is large, this is not at all an efficient method because you will have to sample a lot. This is purely blind search. But the point with this algorithm is that it has no assumption at all on the performance function with respect to the parameters. Since you just sample points completely blindly, you are not making any assumptions on how those points will perform in practice. So the point about policy search method is to consider that we can do better if the function of performance with respect to the parameters shows some local regularity. That's the point of the next slides. So we have two approaches of function optimization. Both approaches rely on some assumption that the function of performance with respect to the parameters is locally smooth, which means that unknown good solutions are likely to be close to known good solution. That's what you see here. Probably if here this is a good solution, you probably have even better solutions around. And variation selection methods just start from a solution and sample around to find a better solution. So you perform local variations and then you evaluate them, and if they are better, you keep them and you move to the next point, etc., etc. And by the other side, you have the gradient ascent methods, which corresponds to the policy gradient methods and reinforcement learning in general, where you follow some gradient from some analytical knowledge. And we have seen in the policy search classes that we have the analytical knowledge of the policy itself, and by following the gradient of the performance with respect to the policy, we can move into the right direction, provided that we have a good enough estimate of this gradient. This viewpoint is presented in that particular paper. So in the first part, I will compare direct policy search methods and reinforcement learning methods. But first, why is this comparison relevant? The point is that if you look at several papers which compare both, you can see that it is by no way obvious that state-of-the-art reinforcement learning methods like PPO outperform evolutionary strategies. So that, for instance, in this paper, which is about the combination, I will go back to it in a later class. The system that the authors propose is the one with the red curve, and we won't focus on that. We will just focus on the comparison between an evolutionary algorithm, which is the green curve, and the PPO, which is the yellow curve. And you can see that, for instance, on swimmer, the evolutionary approach is far better than PPO. On Alpchita, they behave similarly. In those three environments, PPO is better, but on Ant, for instance, the evolutionary approach seems to perform better than PPO. I have to admit that Swimmer is a particular case because PPO was probably not correctly tuned to that particular environment. But here it is less clear whether the poor performance of PPO on Ant is due to poor hyperparameter search from the authors, or if it's true that PPO performed poorly on Ant. Maybe you should check this. Also, the comparison is relevant because there is a growing recognition of direct policy search approaches in machine learning conferences and the corresponding papers. So this one is very cited in the title is Evolution Strategies are a scalable alternative to reinforcement learning. And this one also showed that with a very simple random search algorithm, you can compete with reinforcement learning approaches, and that's a NeurIPS paper. And the general message is that deep neural evolution methods are competitive with deep reinforcement learning methods, even in very challenging benchmarks, such as humanoids, etc. And actually, they are competitive in whole clock time, which means that if you have a large set of computers with evolutionary methods, you can learn as fast as with reinforcement learning. But we have to admit that in fact, you need to do this in parallel with evolutionary methods, so they are less efficient in terms of samples. And that will be the focus of the next lessons, to understand why direct policy search methods are less sample efficient than some reinforcement learning algorithms. So more generally, this comparison will be an opportunity for a deeper understanding of the inner mechanisms of policy gradient methods and direct policy search methods. So the topic of the 4 next lessons will be the following. It seems that deep reinforcement learning are more sample efficient than direct policy search methods, and we want to understand why. So we will investigate potential explanation. It might be the case that the gradient gives the direction of steepest ascent, so the policy improves faster, and we will see that's not the case. It might be the case that gradient ascent does not need sampling because it uses some analytical knowledge of the function under optimization to improve it, and we will see that this is not the correct explanation either. It might be the case that reinforcement learning searches in a better space because it uses information at each state action pair, whereas direct policy search method use only some information about the whole episode without considering single states and actions. And this point might be true, but that depends on the environment. And we will see finally that reinforcement learning methods are better at reusing more samples than direct policy search method. And this is true if the reinforcement learning methods are off policy. That's why some reinforcement learning algorithms are more sample efficient than evolutionary ones. But for instance, PPO, which is on policy, is not that much more sample efficient than evolutionary methods. So we will investigate each potential region to see whether it holds in practice. And then in the second part of this playlist, I will move to methods that combine reinforcement learning methods and direct policy search methods. And you will see that sometimes we find solutions that combine the best of both worlds. So the outline of the next lessons, there will be 4 lessons about comparing direct policy search and reinforcement learning. So I will give a quick presentation of direct policy search methods. I will give more details on policy gradient updates so that we better understand what's happening. And then I will compare both methods in terms of how well they improve a policy at a given step. And then I will compare the optimization spaces in which they perform the optimization. And I will finally focus on the role of replay because that's the key factor. Then I will move to combining direct policy search methods and reinforcement learning methods. And I will show that we can combine both mechanisms to better optimize some policies, or just to better optimize some sampled actions, or to ensure more diversity. And we will see that you can also optimize different things such as hyperparameters or the environment itself, etc. So that's it for this lesson. Don't hesitate to ask any questions.